Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com, and we'd love to talk to you about hosting your telescope or possibly an hourly rental on one of our telescopes. Recently, there was a video that supposedly showed what that author felt was the easiest and best way to process and color map narrowband images in PixInsight. And from my perspective, while that may be the best way to process them in PixInsight, it's not the best way to process narrowband images. And I want to show you how to do that using a combination of PixInsight and Photoshop. So we're going to be using this data of the Rosette Nebula, and we're going to start in PixInsight. And I've already run WBPP, and that's pretty standard, and I've got other videos that show you how to do that. But if we look at the output from WBPP, it's in the master, this is the folder. And if we go into the master folder within the output folder of WBPP, it has created a set of master light files. And let's just take a look at the red, green, blue, and then the 3 narrowband. I'm going to ignore luminosity for now. And if we open those and take a quick look at them with the screen transfer function or screen stretch, we can see we've got pretty much what we expected. We've got the Rosette Nebula, monochrome, oxygen, hydrogen, sulfur, there's hydrogen, and then we have the 3 red, green, and blue. Now, my typical process here, and again, I've done lots of videos on this, but just to summarize it briefly, I will combine red, green, and blue into an RGB image. And we can just do that very quickly by dropping red into the red channel, green into the green channel, blue into the blue channel, solid circle to execute that. And at this point now we're done with these individual red, green, and blue files. So now we're down to 4 files instead of 6. And let's take a quick look at that, and it will probably have a color cast. Yep. So I'll unlink the channels using the link icon in the screen transfer functions dialog. And that's more like what we'd expect to look like. There are some alignment artifacts along the edges where some of the images were shot at a slightly different rotation angle. So that can be cropped out using the dynamic crop tool and crop all 4 of these the same way. But typically what I would do now is run this through some sort of gradient correction. Lately I've been using Graxpert. Sometimes I use the gradient correction tool in PixInsight. Sometimes I use dynamic background subtraction. I'll usually run Blur Exterminator in correct only mode. All of that towards running spectrophotometric color calibration on the color image. And then I'll run Blur Exterminator. I'll stretch the image, and typically my stretch is pretty straightforward. I use the histogram transformation tool and the screen transfer function and just calculate a stretch. And stretching, the way I approach it, stretching in PixInsight is just to get data that's suitable for use in Photoshop. And with 16-bit depth, you've got quite a bit of latitude to work with. So you don't really have to obsess over the stretch. If you're more comfortable using tools like generalized hyperbolic stretch or stretching manually with histogram transformation, or I like to just use the screen transfer function and simply apply the stretch that way. Any of those work. All we're trying to do is get a suitable stretched image that we can apply with the histogram transformation tool, and once it's applied, then the image generally turns white because now it's being stretched for the screen, and we've actually stretched the image so we can turn off that screen transfer function. And at this point I would run Star Exterminator and Noise Exterminator on the stretched files. and do basically the same thing with the narrowband, although they obviously don't get spectrophotometric color calibration. But blur exterminator, stretch the image with the screen transfer function, remove the stars, and also noise exterminator, and then save these as 16-bit TIFF images. So let's take a quick look at that output. If I look back in the folder here, I have saved these 4 files. So these are now stretched nonlinear images and saved as 16-bit TIFFs. There's the sulfur, oxygen, hydrogen, and then the color image of the stars. And what we really want to do is process these in Photoshop. So let's take a look at Photoshop, and I want to go a little bit slower in Photoshop and explain why I think it's the best and easiest way to do it. But I am going to start kind of from the beginning for people who are not familiar with Photoshop. So to start with, let's just open one of those files, and I'm just going to go to File, Open, and navigate to that folder that has the rosette in it, and let's just open the hydrogen image to start with. So there's that same hydrogen starless image that we looked at in PixInsight, and typically when you have an image in Photoshop, you're going to want to do some sort of processing with it. And the processing basically revolves around a couple things. Brightness and contrast, or tone in a more general term. Color, which is separate from brightness and contrast. Do you want it to be more red, more green, more blue? You might do something like sharpening, which you can apply in Photoshop. And you'd like to do all of that in a way that's non-destructive. And by non-destructive, I mean that this file that we've brought in from PixInsight, we never want to change a single pixel in this image. We only want to change how it looks, but not actually change the pixels. And one of the reasons we want to do that is when we use non-destructive tools, we can come back and change our mind. We don't have to visualize how this data is, or how this piece of the image is going to be represented in the context of the whole image. We can look at the whole image and adjust just this piece of it so that it looks correct in the context of the whole image. Maybe that'll make more sense as I go through it. But one of the things we might want to do, if I look at this image, I would say, well, the background looks a little bit too bright. I want it to be dark, but I don't want it to be black. And I am using a black background in Photoshop, which I can get to by right-clicking in the background area and choose black as the background color. And I do that so that I don't accidentally darken this beyond the point where it turns black and we start losing detail. Now, there are lots of ways to change brightness and contrast in Photoshop. Probably the way many of you have learned is that you go to Image, Adjustments, and something like, let's just choose brightness and contrast to start with. And I can change the brightness here, I can change the contrast. Let's say I do something like that, and that's darkening the background. It's also darkening the nebula. And when I click OK, Photoshop has applied those calculations to this layer, and it's actually changed the pixels. Now, if we decided we want to make it brighter again, we could always go back to Image, Adjustments, Brightness and Contrast, and brighten it back up. But much like making a Xerox copy of a Xerox copy of a Xerox copy, you're going to start losing fidelity. Things will get lost because they got too dark. Let's just do that, for instance. Let's accidentally make it too dark. And then say, oh, well, that's too dark. I want to brighten it back up. So if I go back, Image, Adjustments, Brightness, Contrast, and I brighten it back up, where there used to be detail, now it's just blank because we darkened it all the way to black, and then when we lighten it back up, there's nothing there. All it can do is lighten that black area back up to gray, but we can't bring back that data. So we don't want to process this way. So I'm going to use the history palette, and I'm going to go back in time to what it looked like when I first opened it. A better way of working is to use adjustment layers, and that is a non-destructive way of working. And when you go to Image Adjustments, go to Image Layer, New Adjustment Layer, Brightness Contrast. So the difference here is I'm taking this from the Layers menu option rather than from the Image menu option. So Layer, New Adjustment Layer, Brightness Contrast, and I have the option to give it a name. And notice what happened over here in what's called the Layers palette. There's now a second layer, and that's an adjustment layer, and we're looking through that adjustment layer to see what's below. So if I want to adjust this brightness and contrast, notice in the Properties panel, it's showing me that same two sliders of brightness and contrast, just like we saw before. And if you don't see the Properties panel, you can get to it under Windows, Properties. You just check that, and it will show up. So if I darken this, and let's darken it a lot, just like I did before, and I could even save this file and close Windows, close my computer, come back next week, reopen this Photoshop document, saved with the layers intact, and this adjustment layer will be here, and this adjustment slider will be there. And if I want to brighten it back up, I can brighten it back up to what it was originally. I can make it brighter than it was originally. I can change to darken it, but not quite so much. I can turn this layer completely off. I could delete this layer and not have it in the file at all. And I have never affected any pixels on that original layer. Now, brightness contrast is easy to understand, but it's not usually the best tool for adjusting brightness and contrast because it tends to brighten and darken the whole image at once. Sometimes, especially with astro images, we may want to darken the background and yet brighten some of the midtones. So instead of brightness and contrast, I'm going to just delete this adjustment layer, and I'm going to choose a different adjustment layer. I'm going to go to Layer, New Adjustment Layer, Levels. And I use levels a lot for brightness and contrast. Some people like to use curves, which is a more exotic form of levels. Most of the time, levels will work just fine. The advantage of levels, it's a bit like the histogram transformation tool in PixInsight, if you're familiar with that. If we look in the Properties panel, we can see the histogram, which is just showing the distribution of brightness levels ranging from 0 to 255. This is actually a 16-bit image, but it shows it in 8-bit values just so that the numbers aren't so big. And there are 3 sliders underneath the histogram, one for blacks, one for midtones, and one for whites. And then there's a second row down here with 2 more sliders. So let's look at what these 5 sliders do. The blacks slider sets where the black point is going to be, and we can see in this image that we've got some dark gray tones and then a little bit of a tail, but nothing ever goes all the way to black. So if I take the left slider, which is the blacks slider, and move it into the right, I'm saying let's make the black point of this image something like that. And you notice what it did in the image, it darkened the darks, but it didn't darken the midtone much at all. If I want to brighten the bright areas, I can grab the whites slider and move it in towards the histogram. And what I'm doing is basically telling Photoshop that I want to build the histogram from just the range from 15 to 225 and stretch it out to represent 0 to 255. And in effect, that gives me more contrast because I've made the darks darker and the whites or the brights brighter. The mid slider is just midtones, and it makes the midtones darker or brighter. And usually it'll have some effect in the tails also. So for instance, if I darken the midtones to get a little bit more detail in the core of the nebula here, it has darkened the darks too much because you see they're starting to blend into that black background. So I may need to go up to this blacks slider and move it back out to being dark but not black. So you get a lot of very precise control over brightness. But I said we want to add color. The easiest way to add color is going to be to use a hue saturation adjustment layer. Now in this case, I need to, if I go to Layer, New Adjustment Layer, you can see I can't add any of the color-based adjustment layers. And that's because this single image is a grayscale image. And we know that by a couple of ways of knowing it. One is if we look at the file name, it will typically say that it's in grayscale mode rather than RGB mode. We can also go to Image Mode, and we can see grayscale is checked. To convert this to an RGB color image, all I have to do is come down to RGB color, select that. It'll ask if I want to flatten the image. I do not. I want to keep this curves adjustment, although the appearance of the image may change a little bit. And in fact, it did change just a little, and that's subtle differences between how grayscale images and RGB images are mapped into the color space, and that's beyond what I want to get into here. But it still looks okay. Now if we go to Layer, New Adjustment Layer, Hue Saturation, now I can add a Hue Saturation adjustment layer, so now I have two adjustment layers sitting on top of this background of hydrogen alpha. And I want to use the hue saturation in colorize mode. And again, going back to the properties panel, there's a checkbox here for colorize mode. And I want to make a couple changes right off the bat. I want to change the lightness to -50%. And that's somewhat important. And if you can't get the slider right to it, you can just type -50 into the box. I do want to take the saturation all the way to 100%. And you can see now we have our hydrogen shown as red. And isn't that really what we want, is our hydrogen to be color mapped? If it's an HOO image, we want it to be color mapped as red. If this were oxygen, we might want it to be color mapped as blue or cyan. If we're doing an SHO image, we would want our hydrogen to be color mapped as green. So the beauty of this is we have a situation where we have a background layer, which I just unlocked with the lock symbol over here. We have a levels adjustment layer, and we can use that to brighten or darken the image. And we have a hue saturation that gives it color. And if we do this for each of the hydrogen, oxygen, and sulfur, then we can use just this hue saturation adjustment layer for each one of those layers to decide what color we want it to supply or represent in the finished image. For housekeeping reasons, I like to organize each group, each layer, or each filter into a group. So to do that, I'll select the three layers and just tap Control-G on the keyboard, which creates a group. Now you can also add a new group with the icons at the bottom of the bottom right of the window. A little bit different in behavior. If I select these layers and do Control-G, it will create a group and put these three layers in the group. And then I can just name this group hydrogen. And that's kind of the fundamental building block of an SHO image, is a layer group that contains the layer from that filter, a levels adjustment layer to adjust the brightness of that layer's contribution, and then a hue saturation in colorize mode to determine what color that layer is going to provide. We just need to do that to each one of the filters. and then the stars will sit on top, and we can add those back in at the end. So that's the basic process, but let's do that now with all of the data. So to load all of the images, I'm going to go to Scripts, Load Files into Stack, Browse, and that brings up this dialog box. Well, actually, it brings up this dialog box, which it brought up on my second monitor. I'll browse, and here are those TIFF files, and we want hydrogen, oxygen, sulfur, and then the stars. And like I said, I'm going to ignore the RGB and the luminosity. So there's the 4 files that we selected. Click OK. And the load files into Stack loads each one of those files as a layer, so they show up in the Layers palette. And it looks like it I need to close that first one that I opened. So I need to close this. Sorry for that. So we're going to go back to File, Scripts, Load Files into Stack. Hydrogen, oxygen, sulfur, stars. Okay. Okay. Now, if you remember when we opened just the hydrogen, it opened as a grayscale image. In this case, because the stars are an RGB image, it will place this whole document into RGB mode. And you can see that in the file name. It has RGB/16, which tells me this is an RGB color image in 16-bit mode. So first I will do a little housekeeping. I'll put the stars at the top, and then I like to have hydrogen, oxygen, sulfur in that order. You don't have to have them in that order. It's just convenient because you can start, as you navigate through the document, you can kind of subconsciously navigate by position rather than having to stop and carefully read. Now, just like we used a layer group to contain the adjustments before, we're going to put each one of these into its own layer group. So I'll start with the stars. I'll just hit Control-G, double-click to name it stars, and then I'm going to turn it off for now, and we'll just collapse that group so that we don't have it taking up space. We'll come down to hydrogen, Control-G, change the name to hydrogen, and we saw before we wanted to put 2 adjustment layers in here. We wanted to put a levels adjustment layer and a hue saturation adjustment layer. Now, if you have the adjustments panel open, this is a slight variation of the essentials layout where you have the layers palette on the bottom, the adjustments in the middle, and then the properties on top. It's very quick to add a levels adjustment layer just by clicking on the add adjustment layer icon, and then a hue saturation adjustment layer. And we'll close that. We'll do the same thing here. Control-G, change the name to oxygen. Click on the layer, add a levels, add a hue saturation. We'll close that. And now we're to the sulfur. Control-G, sulfur. Somewhat repetitive. Now comes the fun part. Let's start adding color. We want our sulfur to be red, so we go to well, let's look at density first. The background looks pretty bright, so I'm going to go to the levels, darken the background down to dark but not black. I'll go to hue saturation, choose colorize. We want this to be -50. 100% saturation, and in an SHO image, we color map sulfur as red. So notice that as I turn on the layer above, it completely blocks the layer below. And that's the normal behavior of how layers work, but we're going to change that. And again, for the oxygen, I want to darken the background so it's dark but not black. And I want to brighten the highlights a little bit. And we want this to be blue. So again, colorize, -50, 100% saturation. And for blue, we're just going to take this hue slider and move it over to blue, which would be 240 for the hue. And that gives us a blue layer. And lastly, we'll go to the hydrogen. Again, probably need to darken the background a little bit. Hydrogen in an SHO image is color mapped as green. So -50, 100% saturation, and we're going to color map this as green, which should be 120 degrees. Now we may adjust these later. So there's our hydrogen, there's our oxygen, and there's our sulfur, and on top is the stars. Now each one of these layer groups at this point is opaque. In other words, we can't see through it. In order to see through these layers and let them combine, we need to change the blending mode of the layer group. And the layer blending mode that we're going to use for each group is called screen. And you get to that through this drop down where it says pass through. These are the layer blending mode options. And we want to screen. And you can see when I do that, immediately now we see the stars sitting on top of the background, but the only background that's visible is the sulfur. And we can turn those stars off and on. If I turn on the oxygen layer, we see only the oxygen, but again, if I come down to this oxygen group, change the blending mode to screen, now we're seeing a combination of the red sulfur and the blue oxygen. We'll do the same thing to hydrogen, change the screen blending mode to screen. There we have an SHO image with stars. The beauty of this, though, is we can change any one of these settings. And we do that generally through the levels adjustment layer. For instance, if we want the sulfur, let me turn off the stars so it's more visible. If we want the sulfur to be more prominent, we can brighten the sulfur, which is red, so that's bringing more red into the image. And we can even brighten the midtones. And if the background starts to get too dark, we can darken the background. We can even fine-tune the colors. Right now the oxygen is color mapped as pure blue, but we may find that shifting that a little bit more towards the magenta gives us a more pleasing color of blue. We may find that on the hydrogen, if we move it more towards blue or more towards yellow, may give us a little bit more pleasing overall color balance. But just that easily we get to a very good result, and we can change any one of these at any time, now or in the future. If I want less blue, more blue, I can adjust the levels adjustment for oxygen. I can adjust the levels for hydrogen. And each one of these adjustments that's living within a layer group only affects that layer. So this levels adjustment only affects the brightness of the hydrogen. This only affects the brightness of the oxygen. This only affects the brightness of the sulfur. So you have immense control. When we add the stars back in, the stars might look kind of big and blocky. So if we want to manage star size, the easy way to do that is, let me open up the stars, and I'm going to add a levels adjustment layer inside the stars group. What makes stars smaller is making them darker. So if I just slide this midpoint brightness on the levels for the stars, I can darken the stars down to as little or as large as I want without affecting the underlying layer. If I want to make some global adjustments, and let's just quickly collapse each one of these layer groups, all the detail is still there. I can add global adjustments, such as levels, color balance, hue saturation. And these are sitting below the stars and above the 3 narrowband groups. And that lets me adjust, for instance, if I want to adjust global saturation, I can adjust the saturation of the nebula. If I want to change the color balance of the nebula, I can adjust that with the color balance slider. So I can even change the overall brightness of the nebula if I need to. I see a lot of red in the background. Red is sulfur, so I go to the sulfur, to the levels, and darken the darks in the sulfur, and that helps neutralize that. Now I see a fair amount of blue, and it may not be coming through in the video, but now the background is more neutral. So the beauty of this, it isn't necessarily faster or easier than doing the process in PixInsight. After you've done it a few times, it does get a lot faster. But you don't have to visualize in advance how bright you want to make the sulfur before you combine it, because in PixInsight, it's a very destructive workflow. Once you combine those channels, you can't really undo what you did to that channel before you combined it. Just like we saw with the individual, on the individual layer, if we actually adjust that layer rather than using adjustment layers. So this combination of adjustment layers, layer groups, hue saturation to supply color, all that makes this work very quickly and easily. Now you can add some automation to this, and I'm going to be presenting in October on the Astro Imaging channel and demonstrating ways to speed up your workflow both in PixInsight and Photoshop. But just to give you a little taste of how that works, when I went through and created each one of these layer groups and the adjustment layers, basically you do the same thing each time. And Photoshop has actions that allow you to record a series of steps as you execute them and then play them back. So let's close this and go back and just reopen scripts, load files into stack, and browse to find my files. And again, we want hydrogen, oxygen, sulfur, and stars. Okay. And this loads those 4, if you recall, those 4 layers. As long as they're in the right order, in the same order that they were in when I recorded the macro, and that order is with the stars on top, and then hydrogen, oxygen, sulfur. So with the stars layer selected, I can go to my macro. Here's the macro to make all layers, and I can click on the play button to execute that. And there's my SHO image ready for me to fine-tune the adjustment layers to, in this case, mostly darken the background. And minimize the stars. And, pretty quickly, you can generate a finished image. So that's what I think is really the easiest, quickest, best way to color map. If you record a macro to create those groups, it can go very quickly, as you just saw. But the fact that it's non-destructive means that I can save this image and come back and tinker with it more tomorrow and next week. And I've never baked the adjustments into the image. And once you bake those adjustments in, it's very hard to get them out and undo them. For instance, once you minimize the stars and combine that layer, you lose the ability to come back later and decide that maybe you want the stars bigger after all for some purpose. So I hope you found this useful. If you have any questions, be sure to drop those in the comments down below. And as always, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.